So let's try this study check and predict the solubility of a molecule. Again, we will be using this table to determine the solubility. What does this table actually talk about? It's solubility rules for ionic compound in water. An ionic compound is soluble in water if it contains one of the following. Again, you do not have to memorize all of this. If I'm asking you, I will ask you a question about determining solubility, I will give you this table or give you a hint about the compound you're using. So it says all of these positive ions are soluble. All of these ions, whenever it's in a compound, makes it soluble. These two, except if it's combined with any of these. And then it says ionic compounds that do not contain at least one of these ions are usually insoluble. So let's go here and see. So here, if the CDS will ionize, it will ionize into CD and S. So let's see if we have any CD or S's here. No, we don't have. So the last line here states that if it doesn't have at least one, then it's not soluble. So this one is not soluble. Let's try B. B says Na2SO4. SO4 here. Except when combined with there is no Na, so this one is soluble. TB and I2. PP is here, I is here, so anything with I is soluble, except if it has a PP, then no, this one is not soluble. Ni, NO3, NO3 is soluble, so this one will be soluble. So these are the answers: insoluble, soluble, insoluble, soluble. How to write an equation, or how do we determine if which molecule will be precipitating? So, or what is the solid precipitation that will be formed from an equation? So, if we have these two solution, and we need to determine the results, and we need to determine which one will precipitate. So at the end, we will have to use this table again. But looking at this table, we can look at NaO3 that makes this solution soluble. We can look here, SO4 make this solution soluble. So when they will ionize, each one will ionize this way. So let's do this. So PP and NO3 2. So here is the equation, okay, and they want to know what is the precipitate. So we do have this equation here. What we can do is we can think about their dissociation processes. So this one will dissociate or ionize into P, B, and NO3, two of them, right? And here we will have positive ion K, and then SO4 minus, okay? So this is basically the dissociation here. And then they will exchange their ions, meaning that the PP, this is, if you try to remember the types of reaction, this is, try to think about the type of the reaction where the two molecule exchanging their ions. So P will take the SO4, and then the K2 or the K will take NO3. KNO3. So these will be the two molecules. I need to check the charges so I can make sure I wrote my formula correctly. So now we look back at this table and see we do have PPSO4. So SO4 is soluble except combined with PP. So basically that will be our precipitate. The PP will, the K will be with the NO3, so we're good. So the other one will be normal or will dissolve normally. So this one will be, this one will be our PPT or precipitate. So let's continue actually writing this equation correctly or dissociation correctly as it's chosen here. So we'll write down, and this is the equation that you will need to write, 2NO3, okay, plus 2K positive plus SO4 negative. And then we discover that this one will precipitate as it is, and this one is soluble, so give you NO3. Okay, and if you look here, we will have actually to arrange to make the equation balance. We will need a 2 here, and then we will need a 2 here, and then we will need a 2 here. So after writing the equation, we have to balance the equation and then check the components, check the table. And then you can see here we have 2NO3 here, we'll cancel 2NO3 here. We have 2K here, cancel 2K here. So the last equation will be plus SO4. I'm just writing the rest. And this is to confirm that our compound or molecule that will be precipitating is actually the PPSO4. So this is just confirmation. Okay. Another point we will, so here is the cancellation, and this is the last equation, or what we call the net equation. Another topic that we'll be talking about, and this will be the last topic on how to actually make solutions and how to determine the concentration of a solution. So basically, any concentration of a solution is the amount of solute divided by the amount of solution. They have to have the same units. Like if you use, so we have different methods to actually determine the concentration and find out the amount. So again, the concentration is amount of solute divided by amount of solution. Go here. So we can have the amount of solute in grams. We can have the amount of solute in mils or grams or moles. Okay. We can have the solution, the amount of solution in grams or mils or liter. So when you have a formula where you will have the solute in grams and the solution in grams, we call this M divided by M, we call it mass percent. When you have mil and mil, then you have volume per volume, then we have volume percent. Then when you have a gram per mil, which means mass per volume, so it's called mass volume percent. When you have anything in mol divided by 1 liter, we call this molarity, and we'll talk about this in few. So these are the numbers or the formulas that we will get in the problems, and they will ask you determine the mass percent determine the volume percent or the mass volume percent or the molarity of blah 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 solution. So let's see. So the first one is when mass to mass. And of course all of this has to be multiplied by 100 for the percent sign. So mass of solid in grams divided by mass of solution in grams multiplied by 100. Mass of solute is just the mass of solid, but mass of solution is actually the mass of solute plus the mass of solvent multiplied by 100. So let's see a problem here. When 42 grams of water is added to 8 grams of KCl, the mass percent concentration is 16%. How did this happen? So solute here is a KCl, solvent is water. So solid, which is 8, divided by 8 plus 42, the whole grams, the whole solution grams, divided by 100. So you will get 16%. And this is the mass percent. Let's try another one. Again, what is the mass percent of NaOH in solution prepared by dissolving 30 grams NaOH in 12 grams in 120 grams of water? So again, solute, solvent. We need to find out the solution. When you add 30 plus 120, then you will get the grams of the whole solution, which is 150. You divide basically 30, here you go, 30 divided by 150 times 100, you get 20%. And this is the mass percent of the solution. So let's try this study check together. A solution is prepared by mixing 15 grams of Na2CO3 with this grams of water. Calculate the mass percent. You can do it in your notebook now, and I will be doing it with you. So let's do. Okay. So here is our problem. Okay. So now, so again, mass percent equal mass solute divided by mass solution times 100. So mass solute is 15 grams. Mass of solvent 235 grams. But we need mass of solution. So we have to add the mass of solute as well in the calculation times 100. And then you get your calculations, which will be um, one 5 0 divided by 250, I think. 250. So it's around 6%, which is the last one. Let's see. So this is how to calculate mass to mass. Same exact method to do volume per volume. Same thing. So again, here mass volume percent, it's also the same. So here write two conversion factor for each solution. So 8.50% mmNaOH. How would we write this in